First, what is the definition of limit?
Well,
Where it's going to? As it approaches to a number. So, okay. How do you prove that there is a limit?
Okay.
Okay.
Going to the same point and that point exists.
Oh, well,
it doesn't have to exist.
it doesn't have to exist. Okay, so limit as x goes to, let's say, a from the left-hand side is equal to the limit as x goes to the, a to the positive side. Then you prove that that limit exists. Okay, so gotta use basic, you gotta remember this. Okay, what is the definition of limit? This is the definition of limit. Second, what does one-sided limit mean?
Oh, it's only from negative or only from positive?
Coming from one side, negative side or positive side. Does f of x have to exist on that side of x? I mean, it doesn't have to exist. It could be infinite limit, I guess, for a one-sided limit. That's okay. Third question. Oh, yes, we already did that. What's the requirement to prove that it exists at an x value? I'm sorry. What's the requirement? Yes, that one, the first one. And then, when can we apply the limit loss? When can you apply the limit loss? Limit loss like adding them, subtracting them, multiplying them, dividing them. When can you apply? Huh?
Two limits of the same limit thing.
What? No. Well, yes, they have to go to the same x value of. So they have to go to the same x value. Yes. Okay. So when one goes to infinity, the other one goes to a number. We can apply. Yes, limit loss. The other ones also apply too. But basically, both sides have two limits. If you are trying to use the limit loss, then they have to actually exist. Like whether if you're adding two numbers together, two limits together, and there are two numbers, or one of them is infinity. Yes?
Is number 3 like continuity at a point?
What's that?
Number 3, is that continuity at a point?
No, we're just talking about limit. We're not talking about continuity, whether it's continuous or not. Okay, now let me ask you another question. Can you have multiple vertical asymptotes for a function?
Yes.
Possibly.
Yes.
Yes. Maybe. Not really.
Okay, be sure of your answer. Yes or no?
Yes.
That's correct. You can have more than one. Can you have two different horizontal asymptotes?
No.
No. Yeah. Wait.
No.
Yes.
No.
Yes.
No. Break the vertical line test, right?
Yeah.
Vertical asymptote.
Because what if it's at the top and at the
Can you have more than one?
Yes. Possibly. Yes. No.
Yes.
Yeah.
Okay, so tomorrow we're going to talk about, yeah, right. So tomorrow we're going to talk about horizontal asymptote for a few days because it's harder than the vertical ones. All right. Section 1.6, we're now looking at limits at infinity. So yesterday we said we're looking at limits basically that is not really at infinity, meaning like yesterday we looked at when y goes to infinity. Today we are looking at when x goes to infinity. Okay? All right. So, let's review from yesterday. Vertical asymptote. The line x equals a is a vertical asymptote to this graph if what happens with the limit notation? How do you know if x goes to a is a vertical asymptote? Okay, how do you write that as a limit? Limit as
X goes to A.
just a? X goes to a minus, okay, f of x equals infinity
Yeah, or negative.
or negative infinity, so plus minus infinity, right? So how do you know if something is a vertical asymptote? If x is going to a from the left-hand side, y is going to positive or negative infinity, or limit as x goes to what? A from the positive side, f of x is going to positive or negative infinity, right? So this is our definition of vertical asymptote. How do you know there is a vertical asymptote? Well, when you're going to a number, that y has to go up or all the way down. Okay, so that's yesterday. Today, we are going to talk about horizontal asymptote. So basically, what happens when x is going to positive, negative infinity? So we're doing the opposite. So now we're looking at y, meaning the horizontal asymptote. So the line y equals b is a horizontal asymptote of the graph of a function f of x if either. Okay, so now the definition of horizontal asymptote is when x is going to infinity of this function, y is going to b. Okay, so yesterday we said both sides going to a number, it goes up and down, either way, doesn't matter. It's a vertical asymptote. Today we're saying when x is going to positive infinity or negative infinity, that y is actually a number. It just kind of stays at that number, not going up or not going down, it just stays at that number. That number is called a horizontal asymptote. Yeah, okay. So same thing here, limit as x goes to negative infinity, f of x equals b. Okay, graphically, let's show you how that looks like. So let's say that we're going to a number a. This graph goes up or goes down from both sides. We call that vertical asymptote. For horizontal asymptote, we're saying if we go to the right-hand side, which is infinity, or we go to the left-hand side, and it stays at some number, and that number is b, then we call that horizontal asymptote. Okay, again, you're going left and right in infinity. This one, you're going up and down infinity. So that's the difference between horizontal and vertical asymptote. Yes?
Aren't there certain functions that cross horizontal asymptotes?
Yes, but remember how horizontal asymptote is defined. When x is going to infinity. So sometimes it will cross horizontal asymptote, but only towards the origin area. But horizontal asymptote is only defined as goes to infinity, so then we don't quite care what's going on. Yeah. Okay, so now let's solve some problems. This is just review of Algebra 2. So we're going to do the easy stuff today. Tomorrow we're going to do the hard ones.
Wait. So tomorrow. Sorry.
Okay, so horizontal asymptote. Hopefully you still recall from Algebra 2. So you have a y equals to f of x over g of x. So remember your rational function. Rational function means you have a fraction. Okay, so when you have a f of x over g of x, and case number 1, degree of f of x is equal to degree of g of x. So for example, y equals 2x squared plus 1 over 3x squared. What's the degree of the function on the top? 2. What's the degree of the function on the bottom? 2. So when the degrees are the same, do you guys remember what the horizontal asymptote is? 2 over 3. Yeah, so the horizontal asymptote is going to be the ratio of the leading coefficient. The ratio of leading coefficient. So if you still don't know what leading coefficient is, please review your notes from previous 2 years. Okay, ratio of leading coefficient. So that is y equals 2/3. Okay, when the degree are the same. So this year, since you're in calculus, we can't just remember these rules. We have to know why it works this way. When the degree are the same, that means, remember horizontal asymptote is what happens when you go to infinity this way and that way, basically meaning super large numbers. when you're doing super large numbers, then you ask yourself, going to super large numbers, 2x squared plus 1. When x is a super large number, does it matter if you have a 1?
No.
No, so the only part that matters is this part. Okay, in the denominator, there is no other part that is going anywhere else except for this part. So then it's just 2x squared over 3x squared. Then we ask ourselves, which one of the x squared is expanding faster? When it's going to infinity,
It's the same.
yeah, they're expanding the same because x squared is so big because of the infinity that we plug in. So then it doesn't matter. They all cancel out, so you have a 2/3. That's why. Okay, so this year you gotta know why it happens this way, because tomorrow when we do the tricky one, you really have to think about who is expanding faster. Yes.
Is 1.6 on the quiz tomorrow?
Okay. Not talking about the quiz, we're going with the notes right now. Okay, so this is the idea of horizontal asymptote. When x is super large, which one matters? Okay, case number 2. When degree of f of x is less than the degree of g of x. Okay, so for example, y equals, I'm going to give you the same function, 2x squared plus 1, except in the denominator, I'm going to go 3x cubed instead of squared. So the degree in the denominator is now 1 more than the top. Do you guys remember what the horizontal asymptote is? 0. Yes, it is 0. Now again, we're going to ask ourselves why this is the way it is instead of just memorizing this form. Okay, again, in the numerator, 2x squared plus 1, when x is super large, does 1 matter? No, we only care about this one. In the denominator, same thing, right? That's the only one left. Now, if both of them are going to infinity, which one's going to expand faster? The cube, right? Anything that is a higher exponent is going to expand much faster. Now, when it's infinity, it's just super big. So basically, you have like a infinity squared over infinity cubed, right? That coefficient, it doesn't even matter anymore. You're just 2 times infinity, but I mean, really doesn't matter. So technically, it's like this. You have a 1 over infinity, which is 0. You have a question? No.
Me?
Uh-oh.
No, sorry.
That's it. Okay, so this is why it works this way. Next, degree of f of x is greater than degree of g of x. So when the top is expanding faster, so example, y equals 2x squared plus 1 over 3x. Yeah, it's not going to a horizontal asymptote anymore, right? Because the top is expanding faster. Is that what you wanted to say? But this one is a little bit tricky. This one's a little bit tricky. So let's talk about this. When x goes to infinity. Yes, of course, there's no horizontal asymptote no matter what, because the top is expanding much faster than the bottom. But if we want to be really specific, is it going to infinity or negative infinity? Because last year we said if the top is bigger than the bottom, we're going to have a slant asymptote, right? Slant asymptote means it's going to go up or go down. But when x is going to infinity, are we going to infinity or not? Is the limit going to infinity or negative infinity? Infinity. When x is going to negative infinity. Negative infinity. Do you guys know why? Because the bottom, yeah, the denominator, this part is going to be negative, right? So you're going to go down. Okay, so please be careful of if you're going up or if you're going down based on that. Yes, Eleanor.
What if there's like 2x squared plus 1 divided by, wait, sorry, 2x, like, to the 4th power plus 1 divided by 3x squared?
Okay, so basically your question is if the top and the bottom, the highest degrees are both even, then they're both going to go up because you're squaring it, so it doesn't matter.
So it just depends on the square.
Yeah, it depends on the degree, the highest degree. So her question is, yes, we have a problem here because when you simplify, you essentially have this, And then if you kind of simplify, you have like this, right? So then if x is positive, then you go to positive. When x is negative, you go negative. So her question was, what if you have, I don't know, you had, let's say you make this to the fourth and then you make this squared. So essentially you have a 2x squared over 3. Now what? When x is going to positive, positive. When x is going negative,
Positive.
still positive because you're squaring it. Okay, so that's her question. Yes? That is also another great question. So Sophie's question is, let's just simplify this question so it's not, there's not a polynomial, we just have a monomial. So when this happens, you have 2x over negative 3, essentially, right? This one is going to be a little bit tricky. So when x is going to infinity, negative.
So it just switches.
Because the negative times the positive infinity makes it negative. Okay, so f of x is going to negative infinity. And then when x is going to negative infinity, it's going to be positive. Okay, so, your normal multiplying rule still applies. Okay? All right, let's solve. These are easy. As x goes to infinity. The answer is 5. Okay, so just plug it in, right? If you plug it in straight, it's 5 minus 2 over infinity squared. We know this part is 0, so it's just 5. Okay, so easy plug-in usually works. Number 2. If you're seeing this, you're like plugging in infinity, that's fine. But the fastest way is whenever you see that is a question of what is the horizontal asymptote. Okay, so the answer is what? 2. Okay, 2. All right, next. This one. Okay, what is this limit? 0. Good. Okay, the bottom is expanding faster than the top, so it really doesn't matter if it goes negative or positive in the denominator. It will be 0. Okay, this one. Okay, first of all, is there a horizontal asymptote?
No.
No, definitely the top is expanding much faster. The question is this positive infinity or negative infinity?
Negative.
Negative. Okay. Okay, next one. Do you have any questions why it's negative infinity?
No.
Not,
Why
oh,
is there no asymptote? What does that mean?
it's a slant. So basically there is an asymptote. It's a slant asymptote, but the question is just limit. Where is the limit? Well, there is not a specific number. It's going to keep going down, actually, on the left-hand side. Okay, next one. Okay, what's the answer? Ooh, nice. Because there's a negative in front of 5. So you look for the highest degree. Okay, so let's review a little bit. So we reviewed vertical asymptote today, which means when x is going to a number, y is going to infinity. And then we talked about horizontal asymptotes today, which means when x is going to infinity, y is going to a number. The first kind I showed you are the easy ones, the rational stuff. So basically polynomial over polynomial. Okay, polynomial over polynomial, you've seen it for 2 years already. This is the 3rd year, so it should be pretty easy. Okay, now since we have a lot of time left, I'm going to show you the hard ones, which is what we're going to do tomorrow. And we had so much problem of it last year. People were just like, oh, this is so hard, what's going on? So I'm going to spend a lot of time. We're going to start today. Okay. Okay, so basically when we get out of polynomial function, it gets tricky. You really have to think what is going on. Okay, so we are going to check dominance. Dominance means which function is going to go faster. You need to have an idea of all your parent functions in your head. That way you can check.
Can you put that up on the
Let me put it here.
Thank you.
like glue to the wall?
Okay, maybe. Okay, so when x is going to infinity. Okay, when x is going to infinity. We're going to talk about which one is going to go faster. So dominant. So we're going to talk about 3 functions in particular, and you're going to tell me which one is going to be faster. First, exponential. All kinds of exponential, okay? So e to the x, 2 to the x, 3 to the x, all kinds of exponential. Next, polynomial. Remember your polynomials are all your x squared, x cubed, x to the fourth, that kind of stuff. And then you have your last one, which is logarithm. Logarithm, log base 2, log base 10, natural log, all your logs. Okay, let's look. When x is going to infinity, when x is going to the right, which one of those three goes the fastest? Okay, let's look at it. Polynomials are these three, right? The first three, x, x squared, x cubed. Not that doesn't matter, this doesn't matter, this doesn't matter, this is exponential. This is logarithm. So 1, 2, 3, this one, and this one here. Which one is expanding fastest to the right when x equals infinity? Not 2, not 3, not 4, infinity. Okay, talk to your partner. Which one is expanding fastest? Which one is expanding fastest? Infinity. We're talking about infinity. When x is going to infinity. When x is going to infinity, which one is the fastest? Highest y at that same x.
What? The highest y?
The highest y at the same x. All right, let's vote. How many people think the polynomials expand fastest? How many people think the exponential expands the fastest? How many people think logarithm expands the fastest?
Yeah.
Okay, let's check. Let's try some numbers. Okay, we're going to try some small numbers and then we're going to try some large numbers. Okay, so let's try some small numbers, like maybe 10. 0's too far from infinity. We're going to infinity. Okay, then let's try 1,000. That's pretty big. I think beyond that, your calculator cannot handle. So x cubed, so that's polynomial. E to the x, that's an example of exponentials. And then let's do natural log. Oh, I'm sorry, x. What am I doing? Okay, x cubed. That's going to be 10 cubed, which is 1,000. E to the 1,000.
You mean to the 10? Wait, what?
E, to the 10, yeah, sorry.
I was like, wait.
And then natural log 10. Which number is the biggest? Well, try, you got to convince yourself.
One of them.
Well, yeah, one of them. So, because the majority of the people are still a little confused, that's why I need you to do this exercise.
So use our calculator.
Use your calculator for now. Once you understand and you're convinced, do not use your calculator anymore.
Oh yeah.
E to the 10. Oops. E to the 10.
Which one is E? I forgot.
It's literally ginormous.
But on there it doesn't.
22026.
My calculator can't even handle e to the 1,000.
Okay, not natural log 10. 2.303 about.
Yeah, it's definitely
Okay, which one is the fastest?
natural law.
What?
Which one is the biggest y? Exponential. Now, I could do 1,000, but you can see the trend, right?
Yeah,
So if you keep multiplying the same number over and over and over, of course, you're going to not be the same as polynomial.
That doesn't help.
Therefore, when x is going to infinity, the exponential will dominate everything. Okay, it's expanding so fast. At infinity, more so, right? You're doing e to the infinity. That's a huge number. And then the next thing will be polynomial.
higher than a pen.
Polynomial can never beat exponential, even if you have an x to the 1,000. When you're going to infinity, it really doesn't matter.
But why on there does it look
Okay, it's just the way I drew it, but. Okay, the last thing is logarithm. Logarithm is kind of slowly coming to a like a slower rise, right? So logarithm is going to be the smallest. Okay, next, when we go to negative infinity, when we're going backwards, let's think about it. Which one of those three is going to rise the fastest? Okay, think about it. Think about it. Talk to your partner. Which one is going to dominate? Talk to your partner. Talk to your partner. When it goes to negative infinity, what's going on? Which one's going to dominate? Negative numbers.
But neither does E. We know it's which one's maybe it's called.
I think it's either. I think it's
All right, let's vote. Who thinks that exponential is going to expand the fastest?
Yeah.
Who thinks?
Wait, I do.
Okay, who thinks that polynomial is going to expand the fastest? Who thinks logarithm is going to expand the fastest? Okay, we're very confused. All right. Too many different answers. All right.
What does expand mean?
Like y is really big. Y is the biggest.
Yeah, y is the biggest at the
Let's
exponential.
okay, let's try negative
It's
10.
positive. It's positive.
Let's right, the magnitude.
Oh, come on. I'm being
Okay.
tricked over here.
All right, let's try this one. We're putting a negative number. So negative infinity, negative number. So negative 10 to the third, e to the negative 10, log, natural log, negative 10. This is 0.001. No,
What?
I'm sorry. Negative 1,000. Sorry, what am I doing?
Okay.
Okay, this is what? Tiny number?
It's 4.5 times 10 to the negative 5.
4.5 times 4.5?
4.5 times 10 to the negative 5.
Okay, so 0.00045. And natural log 10?
Error.
Nothing.
Does not exist.
Does not exist.
So,
The answer is exponential.
and
It's
then
positive.
polynomial.
Oh, we're getting stuck. So polynomial is going to dominate.
How? The exponential is biggest.
Expanding, meaning it's gonna go down.
How far down are you?
How far down? How far
How
down?
far down can you go?
Okay, so polynomial is going to expand faster than exponential. And then logarithm doesn't exist.
Good.
Dogs don't exist.
Yes, they don't exist to the negative direction. All right, let us solve some problems. Yes, it is a little scary. We can do this though. Okay, so what you want to do is look at who is going to dominate. If they are the same, they're exactly the same, then they're expanding the same rate, then you care about the ratio of the leading coefficient, okay? So same idea as before. All right, let's try. This first one. You have to look at where x is going. Is x going to infinity or negative infinity? Infinity, so who's going to dominate? E. So then it's 3 over infinity, so the answer is 0. Yes? No? Okay. So again, you look at it. This is basically a type of polynomial. This is exponential. Exponential dominates when x is going to infinity, therefore 0. Okay, next. Oh, let's not do these kind of yet. They are... Oh man, skipping so many. Okay, think about it. We have fractional exponent, but that's okay. You can do this. Okay. Raise your hand if you have an answer. Ben.
Oh, tell the answer?
Yeah, tell me the answer.
Infinity.
Okay. Does anyone have a different answer?
Oh god. That's not right.
Okay. Yes, the answer is infinity. Okay.
I know my
Let me explain. Okay, if you look at the numerator, this is the only dominating. This is the only dominating function. In the denominator, this is the dominating function. Remember, if they are both, this is a polynomial, even though you have fraction. That's okay. Which one is higher degree? The top one. We said if the top is higher than the bottom one, it's expanding faster. It's infinity. Yes. The negative sign. Okay. So this is going to be x to the 3/2 over minus x to the 1/2. So that is, yeah, you're right. Negative x. So that should be negative infinity.
No, I'm very confused.
Okay. The highest degree on the top is 3/2. The highest degree on the bottom is 1/2. So essentially, when you're simplifying, it's going to be 3/2 minus 1/2, which is 1. But we still have a negative on the denominator, so there is a negative x. And when x is going to negative to infinity, that negative carries in, so that's negative infinity. Okay. Let's now move on to the ones that actually have these functions. I think you guys can do this. Okay, this one.
Too easy.
Okay, what's the answer? 0. Okay, so if you look at the functions, this function is 2 to the x. This function is 3 to the x. 3 to the x is always going to expand faster. If you don't know, or you cannot be sure, put in some numbers. 2 to the 3rd over 3 to the 3rd, a to the 27. Okay, let's try 4th. 2 to the 4th, hold on, over 3 to the 4th. 16 over 81. And then you can see the bottom is getting much faster than the top, so it's going to be 0. Yes?
I understand that the bottom number dominates, and that's why it's 0.
Yes.
But because they're the same raised to the same power, wouldn't it be horizontal asymptote?
No, they're different function. There's a different function. Yeah, so let's look at one that is similar to what you're talking about. Let's try this one. Yes, but then the base matters. Yeah. Oh, right, only for infinity. Okay, what's this answer? 3/5. 3/5. I'm sorry. 3/5. Because the function on the top is natural log. The function on the bottom is also natural log. So they're expanding at the same rate. So then it's just the ratio. Yes.
It has that confusion.
That's a good question. Let me think about it and I'll get back to you. Okay, next one. This one. 15, answer. Does not exist. It doesn't go to negative infinity. We don't go to negative infinity. Natural log. I feel like this is like more fun than lottery. Okay. Let's try a few more. This one. Okay, answer.
Does not exist.
Does not exist. It's oscillating. It's oscillating. Oscillating things don't exist. Okay. Next. Okay, what's the answer? Good. Does not exist. Let's try. Ooh, this is a good one. Find the horizontal asymptote. What are they talking about? Okay, find the horizontal asymptote. So what are they talking about?
The limit
x goes to infinity, x goes to negative infinity. They want you to find both. Please be careful. The function is strange. Okay? Find the limit. When x is going to infinity, what is that? Yes, it is 1. So 1 over 1 plus e to the negative infinity. 1 over 1 plus 1 over e to the infinity. That's what negative means, right? That's a 0. So 0. Next one. 1. Okay, just look at it. I know you guys can figure it out. Okay, 1 plus over 1 plus e to the minus infinity. 1 over 1 plus e to the infinity, that is 0. Oh, I'm sorry, that's 1.
Yeah.
Sorry. I said, I don't know what I said. Yes, first one is 1, the second one is 0. Please plug it in.